Hello, welcome back to my third video for Lagrange error additional practice. This is problem 3a and 3b. You can see the problem statement right here. So the problem statement says that we want to find a fourth degree Taylor polynomial for ln of x centered at x equals 4. And so first thing we need to do is write the general form of the Taylor series. So the general form you can see is p of x equals f of a plus f prime of a times x minus a plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a times x minus a cubed over 3 factorial, and so on. So we have that written down. I actually need one more term for what we're asking because they're asking us to deal with a fourth degree polynomial. So that means we need to go up to fourth power and the fourth factorial. So the first thing we're going to need is the derivatives of our function ln of x. So we're doing this for ln of x and centered at x equals 4, so that's going to be a is equal to 4. Where the function we're writing the polynomial for is ln of x, we need those derivatives. So I've got the derivatives here. It'd be worth it to pause at this point and make sure you understand how to find each of those derivatives. F of x, f double prime of x, I'm sorry, f prime of x, f double prime of x, f triple prime of x, etc. After you find those, you'll need to find the derivatives at x equals 4. So f of 4 is ln of 4, f prime of 4 is 1/4, f double prime of 4 is negative 1/16, f triple prime of 4 is 1/32, and so on. So with that, we can actually start building the problem. So we're actually going to just start writing the answer. It's a matter of just writing it out and then simplifying things. So we'll start off, we're doing p4 of x. That just means it's a fourth degree Taylor polynomial of, first term is f of a, which is ln of 4. Next term is plus 1/4 times x minus a, so x minus 4, raised to the 1 power, plus the second derivative, which actually is going to be negative. So let's actually make that a minus sign instead. So minus 1/16 times x minus 4 squared over 2 factorial, which is just 2. And then we have the third derivative, so plus 1/32 times x minus 4 cubed over 3 factorial. I'm going to write that as 2 times 3. Simplifies the algebra or the math later. And then the next one is minus 6 over 256, which could have been reduced, but we'll deal with reducing it in a minute. 6 over 256 times x minus 4 to the 4th over 4 factorial. So I'm going to write that as 2 times 3 times 4. And you can see why I wanted to do that, because if we grab another color here, we can start doing some canceling. So that 2 times 3 can cancel out that 6. That's going to make that a little bit easier. And then we just need to rewrite this in simplified form. So p4 of x is equal to ln of 4 plus 1/4 times x minus 4. And then 1/16 divided by 2 is 1/32, so minus x minus 4 squared over 32. Instead of writing it as coefficients, let's go ahead and write it this way. Now this 32 times 2 is, actually let's do 32 times 3 is 96, times 2 is 192, so that's plus x minus 4 cubed over 192. And then I've already canceled that out, so now we just have 256 times 4, which is 1024. So minus x minus 4 to the 4th over 1024. All right, so we can circle that. That's our answer for what we have so far for part A. Okay. And that's the answer. And I'm going to need room to work the second part, so I'm actually going to have to go over top of this. So if you want to write down this answer or look over stuff, make sure to pause it because I'm going to turn off the layer for this. So we'll turn this off. We'll go up. Next part, we want to find the Lagrange error bound. So this is the remainder term. So it's the next term at c, we'll talk about that in a minute, times x minus a to the fifth over n plus 1 factorial. So since we just did a p4 of x, we need the fourth remainder. So that's based off the fifth derivative at c times x minus a to the fifth over 5 factorial. So now we need to just establish each part of this. So r4 of x, let's go back to the other color. I think it works better for what we're doing. So r4 of x, the absolute value of that, because we're looking for the absolute difference, not necessarily whether we're above or below. We need the fifth derivative at c, so that's going to be this number right here. Change back. So that's going to be this value when it's largest on our interval. And remember, the interval we're talking about when is this largest? Between 4 and 4.5. All right, well, since it's a fraction with the x's all in the denominator, then this is at its largest when the denominator is at its smallest, so x equals 4. So that means in this case, our c is equal to 4. Again, that's because the value of the fifth derivative is greatest when on this interval between 4 and 4.5 when x is equal to 4. So we need to do 24 over 4 to the fifth. All right, so 24 over 4 to the fifth, still absolute values here. And then we have to figure out when is x minus a to the fifth the largest on this integral. Well, we already know a is 4. And of course, obviously, on this function, x minus a is largest when x is 4.5. So that's going to be times 4.5 minus a, which is 4, to the fifth power, over 5 factorial. Okay, well, that's our value. If you get out your calculator and calculate that, I could turn on the calculator and look at it, but I think we'll save the time here. If you get out the calculator and solve for that, we find out that that remainder is equal to 6.14. We need to erase 6.104 times 10 to the negative 6. All right, and so it's less than or equal to, actually. And that is our answer for part B. All right, if you have any questions, make sure to contact me, let me know. I'll give you a hand where I can.